as part of the Azure Cloud Commanders Microsoft Learning Room, which is a Microsoft Teams-based community dedicated to your learning, sharing Microsoft content. So if you haven't already joined, make sure you join. So good morning, afternoon, evening, everyone, depending on where you're coming from. If you haven't already, put in the chat where you're coming from, what the time is. We've got people joining from all across the globe, so welcome. So before we begin, I'd just like to inform you that this session is being recorded for future reference and to benefit those who could not join us live. Like I said, we're trying to meet people where they are, and people could be asleep or during the middle of the working day. It's hard sometimes to make these, so having it recorded helps everyone sort of catch up and join, especially if you need to leave halfway through the session as well. So if you do not consent to being in this recorded session, please take a moment to disconnect your line. We respect your privacy and want to ensure that everyone's comfortable with the proceedings. So thank you for your understanding and cooperation. As part of setting up this meeting, I have disabled the attendee names as well. So as part of the recording, you'll just appear as attendees. But if you do come off mute or you do enable your camera, note that those will be on the recording. So I'll just like to go through some of our inclusive session guidelines to ensure that we create a welcoming and productive environment for all our participants. So the code of conduct that we use, emphasizes some of the following points. So be welcoming and respectful to everyone, be empathetic, friendly, open, inclusive, understand, appreciate our differences, be kind and considerate to others. If you do want to have a question, then you can use the raise hand feature. That'll target me so I can see that someone's raising a hand, or you can put it in the chat and we'll get to it when I've got time to have a look at that. In this session today, we'll be deploying container app environment, and that can take about 10 minutes to create. So during that time, it'll be a chance for me to be able to have a look at the chat, and we can have a discussion asking questions that you may have during that period. If you do come off mute, so just remember to mute yourself when you're not speaking. And you can use the little ellipsis button to enable to read the transcript and enable the immersive reader as well. So thanks for your cooperation. Let's get started. So today I'm going to talk to you a bit about the Microsoft Learn AI Skills Challenge and how that one of those sort of features or subcategories is intelligent apps, which is where the container apps applied skill credential sits under. So this challenge is going on at the moment. So it's a Microsoft Learn Cloud Skill Challenge. It has topics, and each topics within the challenge is designed to deepen your understanding through Microsoft Learn modules and expert-led sessions like this session and others being delivered throughout the Microsoft Learn community. So it's not only about just learning, it's about connecting community of like-minded people. So make sure you go and register for the Cloud Skills, the AI Cloud Skills Challenge. At the moment, it does end on the 1st of December, so don't miss out, but it's free to join, and they're really good structured contents to go through some of the Microsoft Learn content around some of those sessions, like intelligent apps and things like that. And you get a shiny Microsoft Learn badge out of it as well. So today we're going to go through a key topic for building intelligent apps, which is container apps, with a focus on the content needed to help understand and pass the deploy cloud native apps using Azure Container Apps applied skills credential. There's a lot of content to cover in a small amount of time, so some sections will have more information than others, but I'm hoping to give you a really well-rounded knowledge covering both the theoretical and practical elements to get you going and enable you to help understand and pass this applied skills challenge. So who am I? My name is Luke Murray. I'm a Microsoft Learn expert at Microsoft Azure MVP and senior consultant from Hamilton, New Zealand. and I'm here to guide you through the topic today. I also run the Azure Cloud Commanders Learning Room, which is where this session is being delivered to. So feel free to connect or reach out after the session to any of my social media, and the YouTube channel has a playlist called Azure Cloud Commanders, which is where the recording will be in as well. But I'll be posting the link up to the recording in the Microsoft Learn channels, team sessions as well. So someone's just asked about the challenge link in the chat. So I will put that in now. Just bear with me. And just for the recording, this is what I'm talking about here. So the AI skills challenge, where you get to choose your own challenge, and this month we've got AI, Azure AI and document intelligence, really useful for exporting things from PDF documents, building intelligent apps with Microsoft Azure, which is where the container apps and helps to allow you to deliver those sessions. Create agents using Microsoft Copilot Studios. There's some Microsoft Fabric in here, GitHub, and Azure for developers using GitHub Copilot, and secure your data at the edge using Microsoft Sentinel Copilot for security. So there's quite a lot of awesome content to come out, but it started on September and it ends in November. But just make sure you check out those sessions and go through and sign up for those cloud skills challenges as well. So 22 days. And you can see the leaderboard here. So yeah, today I'm just going to discuss an essential credential for anyone aspiring to excel in this field, which is to deploy cloud native apps using Azure Container Apps credential. So we're in an era where mastering cloud native technologies has become indispensable. This intermediate credential is crafted for developers and DevOps engineers, equipping them with the knowledge needed to deploy container apps, cloud native applications using Azure Container Apps. So to earn this credential, learners must demonstrate proficiency in deploying cloud native applications through Azure Container Apps. This credential is designed to ensure that candidates are well versed in Azure Platform Services, container-related technologies, and candidates should have a solid knowledge of continuous integration and continuous deployment, so CI/CD. We're going to touch a bit on deploying from Azure Container Registry to container apps using Azure DevOps pipelines today, and that's part of this, one of the tasks that is reflected in the applied skills credential as well in order to pass those. We're going to discuss enabling secure connection between Azure Container Registry and Container App Service, configuring and deploying container apps, scaling our deployments using revisions. Yeah, so hopefully, if you haven't already, make sure after this session that you go through the AI Skills Challenge Learn modules and yeah, go and attempt them. They're free. They're a lab-based credential, so it doesn't matter how you complete the tasks as long as you complete the task. Then they're scored at the end. So when you submit and finish the assessment, you've got 2 hours to complete. Then within a couple of minutes, it gets scored and you get an email whether you've passed or failed. If you've passed, congratulations. If you failed, you can reattempt it again for free, but within 24 or 72 hours after the first attempt. So you can't just keep going and attempting it one after another. There's a period of waiting between the attempts as well. So just be aware of that. So yeah, we'll start with an introduction on Azure Container Apps. So what they are, how do they compare to other Azure Container Services, some of the architecture components that make up Azure Container Apps. Then we'll move on to getting started. So some of the prereqs that we need, setting up our environment in order to deploy. Some of the environment needed I've already pre-configured ahead of this session today, but I'll go through what I've done ahead of time. Otherwise, we would have had to wait for me to deploy those resources. So I'll show you sort of what I've already got set up, and then we can use that configuration to go through some of the demo segments later to actually build our container app as well. So after we've got our environment configured, we'll go through building and deploying our first container app image. And then we'll look at scaling, managing with scaling rules and revision management. And finally, we'll explore the CI/CD and Azure DevOps integration components as well. So let's get into what Azure Container Apps are and how they compare to other container services on offer across the Microsoft Azure ecosystem. So make sure you place any questions you have into the chat. There'll be some time in one of the demos where I will be provisioning our container app and container apps environment. That will take about 5 to 10 minutes. So while that happens, I will be able to have a look at any questions and have a chat. So make sure you use the chat functionality as well, and just keep there's no dumb question. And even if I don't know, we can go through and see if we can find out. So Azure Container Apps is really about helping businesses to streamline their operations, reduce their overhead, enhancing efficiency. One of the key challenges that organizations face is managing complex infrastructure to deploying and scale applications and containers. And this is where Azure Container Apps steps in. So Azure Container Apps enables executing application code packaged in any container without managing the infrastructure. And we'll touch a bit more that later when we compare it to things like Azure Kubernetes Service as well. So with Azure Container Apps, developers can focus on what they do best, writing code and building innovative solutions without the burden of managing the underlying infrastructure. So this platform empowers you to run containerized applications seamlessly, allowing you to scale effortlessly to meet your business needs. So whether you're developing microservices, APIs, or background processing applications, Azure Container Apps provides a robust environment that supports your containerized application, ensuring reliability and performance. So in today's landscape, the ability to develop, deploy, and manage your applications is crucial. So cloud native apps are designed to be dynamic and in virtualized cloud environments, but they can also make use of platform as a service. So PaaS offer compute infrastructure and managed services as well to provide unparalleled performance and scalability. So Azure Container Apps is only one of those components in the overall architecture that you can use within the Azure ecosystem. So Azure Container Apps takes full advantage of the cloud service model, treating the underlying infrastructure as disposable and easily managed. This means that applications can be provisioned in minutes, resized, scaled, or destroyed on demand through automation, ensuring that your infrastructure is already optimized for your needs. So the microservices architecture at the heart of cloud-native systems, and Azure Container Apps embrace this by allowing you to build small independent services that interact through a shared fabric. This distributed approach enhances modularity and makes your applications more resilient and easier to manage. So the containers are one of the backbones of cloud-native applications, offering consistent and portable environment for your code and your dependencies. With Azure Container Apps, you can easily containerize your microservices, transforming your application images into running instances that can scale automatically as needed. This ensures that your applications are always running optimally, regardless of the demand. But as you can see in this image that I've included here, Azure Container Apps is really only one part of the whole Azure ecosystem that you can leverage and use as well. In the demo today, we'll look at creating a service connection between Azure Container Apps and Service Bus as an example. So if there's messages going into the queue from a service into a Service Bus queue, you can trigger Azure Container Apps to respond to those as well. So let's shed some light on how Azure Container Apps might differ from all the other container services offered by the Azure platform. So I know that this text is pretty small. So for those in the recording, on the lower left-hand side of your screen, hopefully above my name, you should see a little zoom icon as well. So the plus and minus. So if you want, you can zoom in. I'll explain a bit more about what these are. It's just a lot of information to kind of fit in the slide. So I had to reduce the font a bit, but you can zoom in if you need to. So let's begin by examining some of the key features and attributes of container apps and comparing them with Azure Kubernetes Service, AKS Automatic, which is probably the closest instance to it, and Azure Container Instances. So what I mean by that is Azure Container Apps does actually run on Azure Kubernetes Service. It's just Azure Container Apps takes a lot of the management away from you. It's really an opinionated way of running container apps offered as a separate solution, but without access to the AKS or the Kubernetes APIs, which for most applications you may not need. So there's cases where you may be running your services on AKS, but actually you could be fine running them on container apps as well. So why complicate things where you don't need to be? But it's really about leveraging the right tools for your right purpose. So Azure Container Apps are designed with low management complexity. This service offers a simplified experience, making it ideal for developers who want to focus on code rather than the infrastructure. AKS, so Azure Kubernetes Service, involves high management complexity requiring deep knowledge of Kubernetes. And the new offering announced during Microsoft Build of this year, AKS Automatic, provides that medium level of complexity, automating some aspects of the Kubernetes environment as well, with things like Prometheus for monitoring and a lot of the services that you from the cloud landscape automatically baked in as well. So it's another opinionated version of Kubernetes service, but you still have access to the Kubernetes APIs in order to run things that you don't need to do. I won't go through every single sort of example here and how they might differ, but make sure you take a screenshot of this if you want to go into it further, or you can watch the recording and pause at this point as well. But it really comes down to what you want to use and what the best thing is for your applications. So some of the aspects that you might use for Azure Container Apps are public API endpoints. So Azure Container Apps is an excellent choice for hosting public API endpoints. Imagine you have a service that needs to handle HTTP requests from users all around the globe. With Azure Container Apps, you can split the traffic between different versions of your container apps. For instance, you can direct 80% of the traffic to the stable version, while funneling 20% to a new revision, allowing you to test and roll out your updates seamlessly. Continuous background processing is another use case. So many applications require background tasks such as data transformation or batch processing to run continuously. Azure Container Apps allows you to run these background processes effortlessly. The scaling of these processes is determined by the CPU or memory load ensuring that your application remains responsive and efficient even under heavy processing demands. Event-driven processing. So in a world where real-time processing is becoming increasingly important, event-driven processing is a game changer. So Azure Container Apps supports queue-based applications, like I touched on previously with the service bus, that provides, as soon as the message arrives in a queue, it can then trigger the container app service to kick off a run space and run that container for you. So the scaling of this method in event-driven processing is determined by the number of messages in the queue, ensuring that your application can dynamically scale to that workload, maintaining your performance and responsiveness. So Microsoft Services architecture is also at the heart of modern application development. So Azure Container Apps provides a robust platform for deploying and managing microservices, whether you're integrating with Dapper or handling complex inter-service communication. So we'll get into some of those. So to start, let's understand the fundamental concepts of a container app environment. So as shown in the diagram, environment acts as an isolation boundary across a collection of container apps. This isolation is crucial for maintaining the integrity and security of your applications, ensuring that each environment operates independently without interference from others. So within these environments, you have the actual container apps themselves. So each container app can have multiple revisions, which represent different versions of the application, allowing seamless updates, rollbacks, providing flexibility and control over the application lifecycle. And each revision can have multiple replicas. So replicas are instances of the container apps that run concurrently, ensuring high availability and scalability. If one replica fails, others will continue to function, providing a resilient and robust feature. So this architecture, so you've got your environment, and then you've got your container apps, and then your revisions and your replicas, offers some numerous benefits such as isolation and security. By isolating environments from one environment to another, as an example, we can have better security and manageability by ensuring security and compliance and applications run in controlled and secure manner. So scalability and flexibility, so the ability to scale those replicas up and down based on demand allows us to efficiently utilize resources and maintain performance. Updates. So with revisions, we can deploy updates without downtime, rolling back issues if they arrive, thus maintaining continuous service delivery. And we'll touch a bit on that in our demo as well. Resource utilization. So by running multiple container apps within a single environment, we can optimize usage and reduce resource usage and reduce cost. Don't worry if you don't understand the concepts now. We'll be going a bit more into them, and they'll make a bit more sense when you start to see things in the Azure portal as well. So within each environment, we have the multiple container apps, or one or more container apps, depending on whether you want to deploy them. And this approach allows us to develop and deploy our applications as independent units, which can be managed and scaled appropriately. So each container app can have multiple revisions. So the revisions represent different versions of the application, allowing us to deploy our updates or roll back, as mentioned earlier, which is very key to continuous delivery and agile development processes. Then you have your pods and containers. So within each revision, there are pods which house one or more of your containers. So the pods are the smallest deployable units in Kubernetes, and they ensure that your containers within them run on the same sort of shared resources and network context from the environment. The containers themselves are the actual instances of your application running the necessary code and dependencies. So for container apps, It's really about the container apps themselves and the environments that you need to manage in the containers, but with the pod management, it's really all done for you. So understanding revisions is essential for managing the lifecycle of your container applications efficiently and effectively. At its core, a revision is an immutable snapshot of a container app. This means that once a revision is created, it cannot be altered. This immutability is a powerful feature that ensures consistency, reliability, and traceability in your application deployments. So each revision is a fixed snapshot of your container app at a specific point in time. This immutability guarantees that the state of your app in a particular revision remains unchanged, providing a reliable reference point for debugging, auditing, and rollback purposes. So revision scope changes are any modifications that can trigger the creation of a new revision. These could include updates to a container image, changes in environment variables, or other modifications in scaling configurations. On the other hand, application scope changes, which might involve internal logic updates, do not affect the deployment configuration and do not create new revisions. You can create new revisions manually, but in a lot of cases, some of the application scope changes do not, but it comes down to how you've written and how you're managing your container apps as well. So the system retains up to 100 revisions before the older ones are purged. This retention policy balances the need for historical snapshots with the resource management, ensuring that you have sufficient history for rollback and analysis without overwhelming the system. And just a note about the cost management as well. You are not charged for inactive revisions. This allows you to maintain a history of your application states without incurring additional cost, making it both practical and economic to sort of use those inactive and keep those inactive revisions around. So revisions are particularly useful when you enable ingress to make your container apps accessible via HTTP. They play a vital role in traffic management strategies, for instance, A/B testing. So you can redirect a portion of your traffic to a new revision while the rest continues to go to the current version. This enables you to test new features or changes with a subset of users before rolling out completely. And we'll touch a bit on that in our demo today. Blue-green deployment. So this strategy involves running two identical production environments, one's being the active blue and the other being the idle green. You can deploy a new version to the green environment and switch traffic between the blue and the green environment seamlessly, ensuring minimal downtime and smooth transitions. So revisions provide a structured and efficient way to manage the lifecycle of your container applications. They offer immutability and consistency, a clear triggering mechanism so you can see the changes within your container apps and based on the revision, and it's cost effective as well because you don't have to pay for those historical states. So let's touch a bit more about the containers themselves. So containers in a container apps environment can use any runtime, programming language, or development stack of your choice. Currently, only Linux-based containers, however, can be used. You can define multiple containers in a single container app. Groups of containers are known as pods. The container in a pod shares the same hard disk and network resources and experience the same application lifecycle. So that becomes very important when you're developing food production in terms of the lifecycle on how your container app environments and how your container apps are developed. You want to keep the same application lifecycle, so the same application together if it's going to be destroyed or replaced or upgraded at the same time. So just be aware of that as well. I think that's general in terms of creating anything within the Azure ecosystem as well. It's how I personally do resource groups. So when you're developing an application in Azure and you want to deploy stuff to a resource group, I always think, is the services and products going into this resource group going to share the same application lifecycle? If it is, then it makes sense to keep them all together. If they're not or they're shared, that's when I think about separating out those services into multiple resource groups as well, because it can get very messy later on when you're trying to clean up resources that are shared between multiple resource groups as well. So back to containers. So containers are an essential aspect of modern cloud native development. They encapsulate an application and its dependencies into a single lightweight standalone executable package, ensuring that the application runs consistently across different environments, be it development, testing, or production. So containers ensure that your application runs consistently across various environments. This eliminates the "it works on my PC" problem, ensuring that if it works in development, it will also work in production. So containers provide a level of isolation between your applications as well. This means that each container can run independently, reducing the chances of conflicts between different applications, especially if they've got different versions of like Node or another dependency running as well. And containers can be scaled up or down to quickly meet the demands of your application. So Container Apps makes this easy to manage the scaling process, ensuring that your application remains responsive under varying loads. And of course, containers are highly portable as well. They can be moved across different cloud providers or on-premises environments without any changes to the application code. So we're going to touch a bit on Azure Container Registry today as well, where we'll be deploying our Azure Container Apps environment and in our Azure Container Apps from an image based in the Azure Container Registry. But we're deploying it to Azure Container Apps, but we could deploying it or integrating it with things like Red Hat OpenShift or AKS. So you can move those containers between your different container execution environments as well. So I'll skip it's the integration with Kada. We're running quite against the clock here. So I'll keep these here and I'll share the slides anyway, so you can go through and read them. But Container Apps integrates quite well with Kada, so Kubernetes event-driven autoscaling. For example, I use this, so the Kada integration with Container Apps with actually Azure DevOps is self-hosted agents. So Azure DevOps will trigger a pipeline. So I'm going to deploy, a Terraform deployment as an example. Azure DevOps will trigger an event based on a Kada Azure DevOps function that will trigger Container Apps jobs to run and immediately add and create that container and then run that session as well. So I'll just skip that. But Kada and Dapper, very useful tools, and Dapper is very useful for integrating other services connecting as well. So let's just dig a bit deeper into getting started and what some of the prereqs you need as well. Obviously, a Microsoft Azure subscription. So first and foremost, to deliver Azure Container Apps, you need an active Microsoft Azure subscription and the permissions in order to deploy it. Networking is also a critical component of any cloud infrastructure, and a virtual network or VNet allows you to securely connect your container apps to other Azure resources and on-premises infrastructure as well. And there are some things you need to be aware of, and such as subnet sizes when you're configuring container apps, when you're configuring and working out your virtual network for container apps, and we'll touch on that in a bit. Obviously, the applied skills is using Azure DevOps and Azure DevOps pipelines in order to deploy, build, test, and deploy to our Azure Container Apps instance. You could do the same thing with GitHub and other mechanisms as well, but the applied skills does touch on Azure DevOps. A container registry, so they're used for storing and managing your container images. So Azure Container Registry is a managed Docker registry service in Azure that allows you to store and manage your container images for all types of container deployments as well, using RBAC, so role-based access control. And obviously, before you create a container app, you need a container apps environment. So this environment provides the fully managed platform for running your containerized application. And it includes the features such as the auto scaling, integrated monitoring, and security controls. So if we go back to those critical information and components that you need to understand around virtual networking and container apps, really comes down to whether you're using workload profiles or consumption-based. So first, we'll talk about workload profiles. So these profiles are designed to support user-defined routes, ingress through a NAT, the network address translation gateway. So when you're configuring your VNet for workload profiles, it's essential to ensure that the minimum required subnet range is a /27. So this configuration allows for efficient routing and network management, providing better control over your traffic flow and security. Next, we'll have consumption only. So unlike workload profiles, consumption-only profiles do not support user-defined routes, egress through a NAT controller, peering through a remote gateway, or any other custom ingress solutions. Instead, they rely on simplified networking configuration for this profile. The minimum required subnet range is a /23, and this ensures there's sufficient IP address space to accommodate the networking needs of your containerized application. So by default, your container app environment is created with a VNet that's automatically generated for you. However, for those of us, especially if you're doing this in a production environment, that you need finely grained controlled over your own network and connectivity to on-premise and other systems over private endpoints, as an example, then you can actually add your container apps environment to your own VNet as well. But just being very mindful that you can't change this configuration after it's been created unless you destroy or recreate the environment again. I just wanted to point this out because when you're planning your environment, you need to be aware. And if those subnet ranges don't meet the minimum criteria, then when you go and create your environment, those subnets won't appear to be able to be deployed into as well. So let's take a look at what I've got set up so far. So if I go to my the screens, hopefully that is good enough. Let me just zoom in a bit further. But for our demo today, what I've got is a code space. So I've just got an ISE, so infrastructure as code repository here, which is public. And in this, I've got my AZ2003. So that's the number of the applied skills app. And yeah, this is only what I've been using because I love code spaces. They allow me to run environments that are actually in containers. And for example, the computer I'm running this from is a Windows-based PC, but this is running Linux and allows me to do and build applications using Linux systems, such as without installing things like the Windows subsystem for Linux as well. So I've got, for the purposes of this demo today, it's a very basic .NET 8 application that I've got running. So it's just the default, actually it was just the default core .NET. Pretty sure something it up. I'll find it after this session ends, but it's just default .NET Core. It's not doing anything fancy. but I've got a Docker file created for it. So I've built this Docker file already. That's going to run our application for us. And then I've connected to Azure. So if I connect to my Azure environment, bloody Teams. Sorry, I've got the Teams shared right in here. So if that signs me in, I can use the extension that is in here. So the Azure Container Apps extension, there's also the registry extension within Visual Studio Code. I've got the Docker extension. I'm pretty sure it's the Docker extension installed as well. And this allows me to, if the demo gods were actually working with me today, let's sign back in again. This allows me to, here we are, see the resources that I'm running, which also includes my registries. So if I go and connect to Azure using Azure Container Registry, I can see in here that this wants to sign in. I've got my Azure Container Registry here, and then my repository. So all I've done ahead of time is got the .NET application, connected it and pushed it up to Azure Container Registry. And so it's sitting there. So if we go into Azure and we go into my resource group here, so this is Azure Container Apps. I can see that I've got a container registry. So that's the container registry that I have pushed my, we go down and repositories, and we can see that this is my AZ2003 project with the latest. So, and then, yeah, that's so all I've got is I've got my Docker file that's been built. I've pushed it to my Azure Container Registry. I've got a private endpoint connection. I've got a DNS zone as well. I've got my virtual network already pre-configured. So for example, I've got my address space and I've got my subnets. So the private endpoint subnet, I've got my ACA subnet. So /23 is the minimum that would be using for this. And then I've also got another subnet for my Azure DevOps self-hosted agent. So I've got this set up ahead of time. I've got my service bus because it's part of the cloud, the applied skills credentials. We need to configure the container apps environment to connect to our service bus. So I've configured a namespace here. I've got our managed identity, which will allow us to pull down from our container apps environment the image using, if I go into here, can I see the role assignments? Yes. So we've got ACR pull. So ACR pull is Azure Container Registry pull. That allows me to pull any image from the container registry using the leafed privilege. So instead of giving this managed identity contributor rights over the resource group, for example, it's just got the ACR pool and that's all it needs. So that's my environment set up. So I've got it all within a single resource group. So which is not usually what you do. For example, virtual network, again, the life cycle of your resources, I would potentially pull that out into another environment. I've got my private endpoint that's been set up for the container registry. I've got my So if we go into the container registry and we go to networking, we can see here that I've got a private endpoint configured because as part of this, we need to only allow connectivity from our own private network to communicate and deliver our images to our container apps environment as well. And that is why, in order to do the CI/CD components, we have a self-hosted agent. Because if you were using a Microsoft hosted agent in order to deploy to container apps, and your container apps is not publicly accessible because it's on a private network, you're not able to do that deployment. So in order to deploy into a container apps environment or any environment that's privately within your own VNet, we need to have a self-hosted agent. So this, for the example we've got here, we've got Windows VM with the Azure DevOps agent software running on it. So as part of the applied skills credential, this self-hosted agent will most likely already be configured for you, so you won't need to go through and set that up ahead of time. But just be aware that that is what's happening. And that self-hosted agent is connected to my, where are we? It's got a public IP because it's only allowing RDP in from my home network, and they always change it on me. But if we go into the network interface, we can see here that it should only be in here it is. It's in my ADO agent subnet. So if we go into Azure DevOps, this is essentially the same repository that I've got here. So within my code space that I've been working to, so I've got my Docker file, I've got my .NET application. I've copied those from GitHub and from the GitHub code space I've been working to into my Azure DevOps repository. In here, I've created a sample pipeline as well, which I'll run through in one of the demos. And within the project settings, I've got my agent pools. So we were talking about those self-hosted agents earlier. And then I've got a default agent pool here. And under that, I've got my AZ2003-agent, self-hosted agent, which is online because this VM is started. So when I'm deploying my pipeline as an example, and I reference the default agent pool, that will allow me to deploy using the self-hosted agent within my own private network as well. So yeah, I've got my self-hosted agent, I've got my Azure Container Registry, my private endpoints, so it's already connected to the network. It's already got a DNS zone name as well, which is done automatically by the Azure platform. So I can see here that that's the IP address it's given it. So my DNS zone is configured, so I can access that over my private DNS. I've got my service bus namespace, and then I've got my managed identity that has the rights for ACR pull in order to pull that information from the container registry. So let's go back. So before I proceed ahead with the next session, I just want to introduce you to the Azure Container Apps Landing Zone Accelerator. So this is not part of the Applied Skills credential, but when you're looking at deploying container apps within your own within your own environment, or you're wanting to look at how you would productionize container apps within the landing zone application context, for example, this is what you'd look at. So the Azure Container Apps Landing Zone Accelerator is structured to provide you with a secure, scalable, and manageable environment to deploy your applications. Example is hub and spoke architecture. So it's allowing you that hub and spoke model, for example, where your spoke would be your container apps environment connecting to a hub environment, which might contain your organization's firewall, things like your VPN gateway and ExpressRoute on premises as well. When you deploy this, it's internal. So it's an internal secure baseline. So very example to what we've got here, where the container registry, for example, has connected you to a private endpoint. The container apps environment will only allow ingress internally, as an example, instead of an external endpoint as well. So it's definitely worth looking at and learning a lot more about how you can merge your container apps environment with your production environment from an accelerator perspective. And you can find that at aka.ms/ACA-LZA as well. So definitely check that out. I'll put it in the chat. You can deploy this using the portal interface as well. So if you've got a test Azure environment as an example, it will help you get going really quickly and have those considerations. Again, not part of the applied skills credential, but I know this is something that's worth calling out because it helps you understand how you could productionize what you're learning. So let's delve into the next chapter, which is building and deploying our first container app. So Azure Container Apps supports any Linux-based x86 container image. Doesn't need or require base image. So it gives you the freedom to bring your own container images and base images that you need. So you can build them outside of the Azure ecosystem, for example, within your own OS, as long as it's Linux-based, x86, 64, and bring those in and run them on the container apps. So it supports containers from any public or private container registry. Container apps enables sidecar and init containers, which allows you to extend the functionality of your applications. So for example, just like the motorcycle analogy, you might have a sidecar application that might be used for monitoring and logging as an example as well. And the key component is the Azure Container Registry. So Azure Container Registry plays a pivotal role by providing a managed Docker registry service based on Docker Registry 2.0. Allows you to store and manage your container images for all types of container deployments, including Azure Container Apps. So by using your Azure Container Registry, you can ensure that your container images are secure, easily accessible, and constantly maintained. There is a security framework as well, and I'll put this in the chat because there is, again, not part of the applied skills credential. However, it's worth keeping in mind when you're looking at setting up container registry services for production. So there is a framework by Microsoft for this Containers Secure Supply Chain Framework. And that's all about really tracking how you acquire an image, how you're cataloging, you're building, you're deploying and running. So make sure you check that out as well. Because the Azure Container Registry has a service in public preview, and I touch on it a bit in my blog article, which allows you to quarantine that image that you might be running, and then you can run things like, is it up to date? Is it patched? It doesn't have the relative security controls in it as well. So what I recommend for production deployments is that you actually operate 3 container app registry deployments, quarantine, catalog, deploy. But that's a session for potentially another day, but definitely keep that in mind. So we'll go through creating our container apps environment, and instead of just clicking through the slides, I'll actually do this in the demo as well. But within the Azure portal, you can do this with Bicep and Terraform if you want as well, but very easy sort of click-based wizard approach in order to stand up and create container apps. So you go through the basics, such as selecting your subscription, resource group, container app name, region. So one of the things that I do when I go into the applied skills credential environment is I go into the Azure portal, and usually you will get access to a resource group. So you'll be able to log on to your Azure environment using credentials given to you. You'll see a bunch of resource groups. You'll have access to read and write to one of them, and that's the resource group that you'll be running and going through your lab for. And I always look at the location of the resources as well. So if you go into one of the resources, so for example, this OpenAI one, and I go and have a look at the location that those resources are running from. So for example, it's East US. That is if I need to create something as part of the applied skills credential, I now know what location I need to deploy those resources in, because there are some services within Azure that are regional Pacific. So if I deploy something into Australia East as an example, I may have trouble trying to connect to that service to another service in my applied skills credential that could be running in East US. So I just thought I'll catch it out because it's one of the first things I do is I'll open up a notepad document within the environment, and I'll just make note of the location of where the resources are getting deployed into as well. Then you select the environment name, the workload, whether you're using workload or consumption profiles, and your networking configuration. And then you go into, do you want to use your own virtual network? So this is creating, this would be the wizard you would go through if you were creating an environment for the first time. If you're adding an existing container app to an existing environment, you won't need to go through this. You would just select your environment that has been created for you already. We'll do this in the demo. And then, like I showed in the prereqs that I've already created, which is managed identity. So managed identities allows us to connect our resources together by eliminating credential exposure. So for example, with the managed identities, we can use this service to connect one Azure resource to another using the managed credential service, which does a whole things in the backend around tokens and certificate management that it does itself. If we were having to deploy that manually, we could expose things like API keys, the wrong type of permissions. You would have to keep an eye on like key expiries, things like that. But this is managed for you and allows you to do things. And when we're using user assigned managed identities, you can deploy them to multiple resources, so independent of your container apps lifecycle as well. Sorry, I'm just going through my notes to see if there's anything. I'm just wary of time, if there's anything worth calling out. But hopefully you've all touched on what and used managed identities before. There is user assigned managed identities, which is what I've got there, which is a user assigned managed identity that I can, for example, have the rights to connect to my container registry for, but I can also add the rights to connect to my service bus namespace as well. If I was using system assigned managed identity, so my container apps environment was using a system assigned managed identity, that managed identity could be used to only connect to multiple things using that system outside of the lifecycle of that resource. Ingress. So when you enable ingress, you can choose between two types of ingress, so external and internal. So external allows traffic from both the public internet and your container app's internal environment, and internal, which allows only internal apps within your container app environment to connect. So each container app within an environment can be configured with different ingress settings. For example, in a scenario with multiple microservices apps, to increase the security, you could have a single container app that receives the public requests and then passes them to a backend service. So in this scenario, you would configure the public-facing container app with the external ingress, and then the internal-facing container app with the internal ingress as well. So with HTTP ingress enabled, your container app has support for TLS termination, HTTP 1.2, HTTP2, support for WebSocket and gRPC, HTTPS endpoints that always use TLS 1.2 terminated at the ingress point. You can expose ports that are 80 for HTTP, port 443 for HTTPS. By default, HTTP requests coming into port 80 are automatically redirected to HTTPS on 443. You can add things like fully qualified domain names. The request timeout second for HTTP ingress is 240. With TCP ingress enabled, your container app is accessible to other container apps in the same environment via its name, which is usually defined by the name property in the container app's resource and the exposed port number. So it's accessible externally via its fully qualified domain name and exposed port number if the ingress is set to external only. So you can mix and match, so you can have container apps that are externally facing and then only internal as well, especially if you've got those background processes wanting to talk to each other. Secrets. So Azure Container Apps allows you to bring in secrets. Very, very useful. So you can either have the key value pair directly defined within the Azure portal, or more recommended is you can bring in your secrets from a key vault reference as well. So you have a key vault, and then you have the managed identity of your container app or your user assigned managed identity that you've got configured, allowing you to read secrets from your key vault, and then you set that up and allow the secret to be read. That way you can make sure that things like if you're bringing in certificates as an example, you're always grabbing the latest one from the key vault without giving people the ability to touch your application and read. All they need to do, all your automation needs to do is update the key vault with the latest version of your secret or your certificate, and then know that your application will pick that up. So if we start to look at the storage for container apps, so you've got container apps files, ephemeral, and the container file system itself. So each type of storage comes with its unique characteristics and use cases, and understanding these will empower us to make the most of our containerized applications. So if we talk about container file system, so this system is temporary and deleted when the container is shut down or restarted. Files written to the storage are only accessible to processes running within the current container. One important thing to note is that there's no capacity guarantees with the container file system storage. The amount of available space is dependent on the disk space available within the container itself. This type of storage is usually suitable for temporary data that does not need to persist beyond the life cycle of the container. Next, we have the ephemeral volume. So ephemeral storage is scoped to a single replica and persists files for the duration of the replica's lifetime. So even if a container within a replica restarts, the files in the ephemeral volume will remain. So this storage can be mounted by any container within the same replica, and a single container can mount multiple ephemeral volumes as well. So the total storage is determined by the number of vCPUs allocated to the replica. This makes ephemeral volumes ideal for scenarios where data needs to persist across container restarts, but not beyond the life cycle of the replica itself. And then lastly, and this is the most used case, will come down to Azure file volumes. So this type of storage allows files written under the mount location to be persisted to a file share. So an Azure file share, for example, making them accessible via the mount location. So multiple containers, even those in different replicas or revisions, can mount the same file share and access the files written by any other container or method. Furthermore, more than one Azure file volume can be mounted in a single container at the same time, which makes Azure File Shares Volume a robust solution for scenarios where data needs to be shared and persisted across multiple containers and lifecycles. And cloud service connections. So Azure Container Apps provides a service connection feature that not only manages the configuration of network settings, but also seamlessly connects various services, such as Service Bus as an example. The service connector facilitates the connection between Azure services with remarkable ease. So with just a single Azure CLR command or a few steps in the Azure portal, which we'll go through in our demo, you can link services without the hassle of understanding and doing this all manually and via software-defined, so SDKs or API calls as well. It's all built in, allowing you to really connect one Azure service to another. And the Azure Service Connector supports an ever-growing list of databases, storage solutions, real-time services, state management, and secret stores, allowing you the capability to ensure whatever service that you're working with, the Service Connector can help. Another critical feature of the configuration of network settings, authentication processes, and management of connection environment, variables, or properties. This ensures that your connections are secure, efficient, and tailored to your needs. And one of the most compelling arguments of using the Service Connector is the ability to validate your connections and provide suggestions to fix any faulty connections. So just like most Azure services, you can bring out your health diagnostic services. Is it actually running? Is it able to connect and communicate with that other Azure service that you're trying to connect to and your application systems are trying to use? You can bring in the service connection health diagnostic data to understand and troubleshoot that services as well, and securely connect using your managed identities without having to open up other services or other things that might be very problematic to troubleshoot and maintain securely in the future. So let's go through a demo. So we've been asked to configure a container app that meets some of the following requirements. It's deployed to a VNet. So it pulls an image from our container registry. It authenticates using a user-assigned managed identity. It uses the container apps to connect to a service bus instance using the .NET client type. The application can run up to 2 replicas that are added whenever there are 1,000 concurrent HTTP requests. So we want it to be able to run up to another replica whenever there's over 1,000 HTTP requests. So that's our requirements. Let's go through how we would do that and set that up within the Azure environment. So if I go back to my Azure portal, and I go into my environment here, we can see I've already got the user assigned managed identity that was required, but we need to deploy our container app. So we need to pull the image pull a image from a container registry. So within my container registry, I've already got my image here. So that was my just .NET sample application I've created, built my Docker file, pushed it and built to my container registry. So now we need to create a container app that will run it. It needs to be deployed within our own VNet. So within our virtual network that we've got here, we can see the subnets. And so it needs to be deployed within our own VNet in the ACA subnet. And we need to connect the container app environment to our service bus. So let's go through doing that now. So in order to do that, we'll just click on Create. And then we'll find container apps. Again, just like most other services, you can go through and do this with infrastructure as code as well, but within the context of the applied skills credential, the Azure portal is probably the easiest way to get going without having to worry about managing those dependencies. One of the best things about the applied skills credentials themselves, because they're a lab-based environment very similar to this, it doesn't matter how you achieve something as long as you achieve the goal that's been asked of you. So if we go into container apps, we're going to create one. We're going to specify our subscription. We're going to specify our resource group. I'm going to put in the same resource group as my other dependents. I'm going to specify my container app name. So I'm going to call that ACA 2003. I'm going to, sorry, I'm just quickly checking. My list, yep, I'm going to call it this. I'm going to use a container image as my deployment source. I'm going to bring my own container registry, my region. So I'm going to do exactly what I mentioned I always do on my applied skills credentials, is have a look in where they're deployed to. And I can see, because I'm based in New Zealand, the closest Azure region to me at the moment is Australia East. So that's where I've deployed my resources into. So that's where I want to make sure. And because I've selected this resource group, it has automatically selected Australia East for me. Now I don't have a container apps environment already created for me. So I'm going to select Create New. So we're going to give it a name. So I'm going to leave this as managed environment, and then it's generated a name for me. Do I want it to be zone redundant? So do I want it split between my container apps environment and the apps within it to be split between all three availability zones? Requiring VNet, it does require VNet integration. In my demo environment, I'm not going to do that. However, if you're doing that in production, I definitely recommend you do that, because if one availability zone fails, as an example, then your application will continue to run because it's spread between the other two zones. We're going to leave this. We're just going to use the defaults here. We're going to go into monitoring. So our container apps environment, we're just going to actually get it to create a log analytics workspace for us. I could put it into Sentinel if I wanted to that I'm running here, but I'll just leave that as default. Really, it comes down to the requirements, which is we need to use our own virtual network. So we're going to go yes. We're going to select our virtual network. and then we're going to select our subnet. So when I was talking about the requirements for the subnet address ranges for your VNets earlier, this is what I meant. This is showing the subnets that are large enough that they support our container apps environment. But if I had a very small subnet as an example that didn't meet the minimum criteria required, this would not appear here. This would not appear in the subnet, and so you would be missing it. So if within your environment, if you're going through and you can't see your you can see your virtual network, but you can't see your subnet, make sure you check out those subnet address ranges and make sure they meet your requirements. So I'm going to deploy this container app environment into my Azure Container Apps subnet. I'm going to leave it as external. I'm going to leave the infrastructure resource group as default. So what this means is that it can create, when it creates the compute nodes required to run your containers themselves, usually that, just like Azure Kubernetes Service does, usually it puts the node pools into its own infrastructure resource group. But so if you've got specific naming requirements, this is where you would start to pull it in. But in my example, I'm just going to leave it default. It doesn't matter. It's going to create those resources for me. So select my subnet. I'm going to create my container apps environment. So now we've got our container apps environment created. Now we need to create our container apps to put into the environment that we've created. So I'm going to go next. And this is where we can either use a quick start image, so an image that's, or like a simple hello world container, but our requirements is that we need to pull it from an Azure Container Registry. So in my example, I'm just going to go, yep, we've got our container name, which is ACA AZ2003. Our image source is going to be Azure Container Registry. Our subscription is going to be the location of where we're hosting our container registry. We're going to select our image, which is late. I'm going to select the latest because that's the only one that I've got in here that I've already got within my container registry that I pushed from that default .NET file earlier. I'm going to leave the command overrides. I'm going to leave the deployment stack. I'm going to just leave this as default. If I had any environment variables, I would add them in here. I'm going to select next. We can enable ingress here. I'm going to do that later, but we can enable the ingress traffic here. And this is what we were talking about earlier about external and internal egress. So internal is limited to the container apps environment, and external is allowing you to manage the traffic elsewhere. And that's when you use things like your application logic or network security groups and firewalls to control access to that environment as well, and HTTP and TCP ports. But we're just going to leave this unchecked. We're going to go review and create. It will run a validation, and then we're going to click create here. And that will create our, hopefully, if the demo gods are willing, that will create our container apps environment from our image that was in our Azure Container Registry service. So while we wait for that, any questions or comments in the chat? I know we've gone a lot over time here, but hopefully it's useful. But yeah, any thoughts? It's like watching the paint dry. I did debate whether or not I should have done this part earlier, but I think this is clear. This is an ideal process to show you because this is one of the requirements of the Applied Skills Challenge. My coffee's getting cold. If we've got operation details, we can see that it is running, and it's running for 53 seconds at the moment. So we'll just let that go. We should also be able to see within our virtual network, we should also start to see network interfaces start to populate in here as well within the ACA subnet. You have to keep in mind that this is deploying quite a lot under the hood in terms of not only the container apps ecosystem itself, but the Azure Kubernetes service components and everything else under the hood as well. So this is why this part takes a while. When you're deploying your container app services themselves, it won't take as long. It's just the initial creation of the environment that it needs and the rest of the ecosystem that it's deploying that takes the longest time. While that's created, actually, let's go into here, and we will make sure that our pipeline which actually has tried to run when I set this up the other day, but I'm not going to run that. Let's go into edit. We can see here that the pool name is default. So that's good. So what that means is within our agent pool settings here, by default, a lot of the deployments may just be Azure pipelines. So what that means is that by default, when I'm deploying pipeline, the pool name will be Azure Pipelines as an example, and that will pull from the Microsoft hosted agent. So they're the cloud-based agents managed by Microsoft, and they won't have access to your internal network. So what you want to do is when you stand up a new, lost my mouse for a second there, it's still going, oh, that's completed, but I'll finish it up here. So if we go into agent pools and then we go for default and then agents, we've got our self-hosted agent here. So what we can do is we click on new agent. If you were setting this up for you in your own environment on your first time, you go to new agent. You can download the agent, and you can install and configure that agent. So in this example, I've got this running on a Windows node. So it's just a Windows-based, I think it's Windows Server 2022 VM running. Very simple with a private endpoint that's connected to my VNet. And it's very simple to going. It's essentially download the agent, configure it. So in order to configure it, you will need things like a PAT token. So you can go into here and grab in your personal access token that allows the agent to communicate with Azure DevOps. And then once you've got your personal access token, you'll also need the name of your organization. So in this example up here, it's Luke Murray NZ, but you will need your name of your organization as well. So you'll need your PAT token and then your organization name. You put that into the configuration of the agent when you go and install the exe and set it up. And I'll ask you things about, do you want to run this as a service? For example, do you want it to start when the VM starts, and et cetera, et cetera, et cetera. Self-hosted agents are very useful when you're running definitely running services that you need to communicate privately within your own private environment, but also if you've got dependencies that may not be installed on the Microsoft hosted agent as well. So you might be running custom tools that need to be installed on your self-hosted agent that you can then use the pipelines to call those. So that's all I've done here is I've stood up a VM running Windows Server 2022. I've gone into my organization. I've generated a PAT token, valid. I've gone into new agent. I've downloaded the agent. I've ran the config, set it as a service to start. And that allows Azure DevOps. Then within my pipeline, I'm using the default pool name, which is my self-hosted pool name. Oops. And then that allows me to run here. So I've done a very naughty thing by having the Azure Container Registry password in here, but within my pipeline, I've added a step. So we can go to tasks here for Azure Container Registry, Container Apps. Deploy. We can specify our connection. So how are we going to connect to the Azure subscription? We can specify the registry name. So and then the username, and then the registry password, the Docker file. If we're going to use this process to build our image and then push our image into the container registry as an example, we can deploy our container image from our Git repo directly into the by pointing it to the Docker path, the container app's name, the resource group, the environment that it's running, the application stack. So I actually don't have the container app name or environment filled out here ahead of time because I haven't created them. So that's, while we waited, I just wanted to show you sort of the agent process and the current config of my Azure DevOps pipeline. So if we refresh that, so let's go into our newly created container app. So our newly created container app, is working. And we've got it connected to our container apps environment. So we can see that it's a workload profile. We can see the version of Kata and Dapper already installed. And these versions are managed by Azure and Microsoft, so they're automatically updated by them. We can manage our certificates. Azure, we can manage the persistent or the storage types that we talked about earlier. We can specify we can add in the user assigned managed identity. If we've got custom DNS names, this is where we can add it in, and of course our applications themselves. So if we go into here, we can see we've got a container apps environment running that should have one. So it's running with one revision at the moment. So let's look at our requirements. So deployed into the subnet, pulls an image from the container registry, now authenticates using a user assigned managed identity. So if we go into our identity, we can specify user assigned, and we can add in our user assigned identity. So in my example, I've got my user assigned identity in here. I'm going to click on add. And this allows the container apps to utilize the user assigned managed identity. In order to talk to other services. So now we need to connect our container app to our service bus instance. So in order to do that, we're going to go into the service connector here. We're going to select create. So remember earlier I demoed that I'd already created the service bus instance namespace here. That's just a standard next finish service bus namespace created. It's not doing anything fancy. It's just on the basic tier. I'm going to click create. I'm going to specify our container. I'm going to specify our service type. So in our requirements, we had to pull it from a .NET client. So I'm just going to put in here. And of course, that doesn't work because why make it easy? The service type is actually service bus. I think I need another coffee. The connection name doesn't really matter. For our purposes, this is the client type here. So this is where I specify the client type will be .NET. So our service type. So these are when I was talking about earlier about service connections and all the different types of database queue system messaging services that you can connect natively from your container apps to other Azure services. This is what I was talking about. Really, we can connect it to Kafka, Cache for Redis, Cosmos DB, DB for MySQL, Key Vault, like Service Bus, SQL databases. We can connect it to a plethora of the storage services, so blob, file, queue, table, OpenAI service, which is a new one, some of the AI and multiple cognitive services as well, but for what we're going to do. And more services will be added over time as well. So just keep an eye on Azure, some of the Azure updates for that. But if we go down to Service Bus, we want to connect it to our Service Bus. We want to select the client type to be .NET. So we're going to select that. Next, we're going to click Next Authentication. Now we're going to select Use our User-Assigned Managed Identity. We're going to select our User-Assigned Managed Identity. We can also use System-Assigned Managed Identity. We could connect using a service principal or a connection string, but I recommend not doing that. For our purposes, we're going to use the User-Assigned Managed Identity that we have. We're going to select Next. We're going to allow the service connection to automatically configure the firewall rules to allow access to the service bus namespace for us. So we don't need to go in and manage that ourselves. We're going to select Review and Create. But we could also use it to connect to private link, and we can enable service endpoints as well if we wanted to. But in this example, in this demo, we're just going to allow us to automatically configure the namespace firewall settings for us. So we're going to select Review plus Create, wait for it to do its validation. Hopefully it will work. Validation's passed, so now we're just going to click Create. And the service connection will also register the Microsoft.Service Linker resource provider to our subscription if we haven't already registered it. I actually don't know if I have, but we can find out by going into our subscriptions. I'll just click on subscriptions. We can go into our resource providers. So resource providers allow, this is not part of the applied skills assessment, but it's worth knowing how they work. So if we go and find the service. So resource providers really allow access to the APIs for different services and registration and it's been registered. So by default, for example, if I was to go into, if I was going to attempt to deploy I don't know, Azure Arc or some of the Microsoft Business Continuity services as an example, Unified Protect and Backup as an example, I may not be able to do that by default because the APIs for that specific service aren't registered and enabled on my subscription. So when you're managing things like your Azure environment in production, you can use things like Azure policy to restrict what gets created in those services. So only allow, web apps to be created in specific resource groups as an example. But resource providers are very handy as well, because you can specify the resource types that you can create by default. So if you're doing things like subscription vending, you can have the resource types for like unified protected items, for example, within the Microsoft Business Continuity provider. You could have this registered by default, or you could make sure it's not enabled and make sure that no one deploying to that subscriptions has the right to register that service, and that prevents it from getting created. So you can do some really cool things like, for example, Playwright. So that's a testing service by Azure. But in this example, and when you're using the wizard to create stuff in Azure, usually in the back end, it will go in and verify that the resource providers and the APIs and services have been enabled. And if it's not, and you've got permissions, the wizard interface within Azure will actually do that in the background for you, like it's done here. It's registered our service linker. So now we've got our service bus connection. So it's automatically added in our fully qualified namespace domain name, and then our client ID as well. So that will be the client ID. So again, we didn't need to manage that. The service connection process has done that to connect to our service bus for us. So we've gone through and we've connected our service bus instance. So if we go into our service bus, we should be able to see I actually haven't looked, so I actually don't know where and if it is. So not identity and not networking. I was wondering if we could actually see the connection within the service bus namespace from the container apps. Service bus configuration properties. But we actually can't see it on the namespace itself. We can see there's a role assignment that's been created in here in the activity log. Anyway, that's I'll do some digging. But yep, so we've got our, so if we go back into our container app and we go to our service connection, we can see that got our service bus connection here. We can go in and validate that as well, and that will validate and make sure it's running and healthy. And that's what I was talking about earlier in terms of the diagnostic settings and the health data. We can see that the connection status is a success. So the container apps environment can talk to the service bus. Very, very useful. Right, our next step is to configure the replicas. So we want to run up 2 replicas we want our container app to run up to the 2 replicas that will be added whenever there is 1,000 concurrent HTTP requests. So let's go and do that. So we've got our container app already open here. So we go to revisions and replicas. We notice that our revision mode is set to single. We will not edit that at this time. Okay, what this means is when we change, if we're doing things like a blue-green deployment, for example, if we want 20% of, so this is revisions, this is not replicas. What we need to do here is configure a replica, but I will go into revisions now, which is, so revision mode single means that you're only run one revision, so one revision of your application. If you're doing things like blue-green deployment, or you want 80% of traffic to go to your old version of your application and then 20% to go to your new version of your application, you would come in here and you would change revision mode from single to multi-revision mode. That means that you can, whenever you're spinning up a new revision, you can actually come in here and you can label one to be green, blue. You can redirect 20% of the traffic from one version to another version. We can run through a demo of this shortly, but for our version here, we're just going to have a look at the scale. So we're going to grab our active revision name here. So we're going to grab our ACA, our revision name. Then we're going to go under scale. We're going to select minimum replicas and maximum replicas. So a minimum, because it's a container apps environment and we can scale to 0, we can scale a minimum of 0, and we want our max replicas because we want to run up to 2 replicas whenever there's over 1,000 concurrent HTTP requests. So we set that to 2 because we don't want it to scale out to quite a lot more, because then it would we could be over provisioning for what we need. Under scale rules, we're going to click on add. We're going to give the scale room a name, such as scale rule HTTP. We're going to select the type. So this is going to be HTTP scaling, because we want to scale out whenever there are 1,000 concurrent HTTP requests. We're going to edit the number of those concurrent requests, so that's 1,000. We're going to click to add. So this scale rule allows us to have a minimum replica running all the time. We want it to go to a maximum of 2 replicas, but only do it when the HTTP scaling rule is up to 1,000 concurrent HTTP requests. So we're going to save that, and that's going to create a new revision for us based on the revision that was running. And we should see our revision update as well. So the reason I did copy, so if I open up the good old-fashioned Notepad document, reason I copied that revision name earlier was that we should be able to see, we can see, because it's a single mode replica, still, it's running up the new one, which is the LM. See, this is the old one here. So it's automatically creating our new revision for us, because we've added in the scale rule, and it's automatically deprovisioning the old one for us. So we can see our revision has changed. And what's happening in the background is that the load balancing between hitting this endpoint will be updating as well. So that revision still swapping across, I think, is it LM? I think this is a really bad example because what I've got for my application is just it doesn't matter for the applied skills credential, so it's just a .NET example application, but it should still, the active revision should be running. But yeah, we can see that our old one is now inactive and our active one is now here. Just wary of time as well, so we'll go through to the DevOps pipeline. So we've got our container apps, a managed container app environment. So let's go into the Azure DevOps pipeline and let's fill in the container app name. So our container app name is ACA AZ2003. We're going to go into our pipeline AZ2003. Is there anything else that we need? We've got our resource group name. Let's give it a go, shall we? So we're going to save and validate. So what this pipeline is going to do is deploy our image from our Azure Container Registry into our container app for us. So if we run this pipeline and we give it the permissions in order to run it, I half expect this is not going to work for the first time. We'll have to give it permission to talk to the agent pool, and then we need to give it permission in order to connect to the service principal that's connecting to our Azure environment. This can get a bit finicky. Oh, we can see it's also kicking off our job on our agent. So that's our self-hosted agent. So it's starting to download all the required dependencies and the tasks onto the agent. I actually haven't tested this agent, so hopefully it works. But one of the key things really here is the Azure Container Apps task and the Azure Container Apps app deploy. This is all in the Microsoft Learn modules as well. And making sure that you've got the right password, you've got the right username in the registry name, and then you've got your service connection already configured as well. It failed. Why did that fail? Possibly because I don't have the AZCLI commands installed on my Azure DevOps agent. Okay, well, that's a fail, but the Azure DevOps agent that you'll be using in the applied skills credential has already got it installed. But yeah, unfortunately, that was a complete fail. But let's just assume that worked. I should have tested this ahead of time. That was my bad, sorry all. But if we go into this task, Azure Container Apps deploy, I'll just show you how to find the information that this task will need. So the container app name, so if we go to our container app, we can grab the name from here. So the container app name is going to be ACA AZ2003. So if we go in here, and our container app username, so this comes into it is in authentication. Just bear with me, sorry. She might be under the environment. Just quickly checking. So our container registry name, the Azure Container Registry username. Oops. Container registry username. That's why I couldn't find it. Under properties, we need to make sure enable admin user is also enabled as well. And then this is the logon server that we're going to use. So the logon server will be automatically added by our Azure DevOps pipeline. So within access keys, we can see that our username, our registry name is here, and the admin user is enabled with the username. So the admin user name is always the name of usually the name of the container registry. So within the Azure DevOps pipeline, we're going to specify the Azure Container username. We're going to specify the password. So we're just going to show this and copy the password. We're not going to worry about the Docker file path. If we were going to be using we could be using this to actually build and deploy into our container registry. But for example, with this task, what we want to do is deploy from the container registry into our container app. So we're just going to leave that, but we will need the Docker image to deploy. And in order to do that, in fact, you can see here the image to deploy is our container app login. So it's our registry. So registry name.azurecr.io. And then it is the image and then the tag of the image that we're going to deploy into our container apps environment. So in order to grab that, we go into our registry, then we go to repositories, then we click on our image, and then we select latest. And this is where I usually just pull it from myself, is I'll grab the Docker pull. So this is the image that we need. So that's the container registry, the container image, and then latest from our registry. So I'm going to grab that. I'm going to put it into our Docker image to deploy in here. Our Azure Container App name, which is, I had opened before. So if we go into our Azure Container Apps, just pull in our Azure Container App name. And then we can add some more things, like we can add our Azure Resource Group name. So our resource group, the name of our Container Apps environment as well. And I think the location, and that's all you need to really add in here. And then you can save and validate it and then run that. So I've kind of skipped ahead a bit in terms of, let's just go back to sort of the continuous deployment options. So as developers, whenever you push the new commits to a repository, you can have it trigger a workflow, such as your Azure DevOps pipeline, to push out and update your container image. And then the Azure Container Apps then stands up. If it determines that the latest version of your application is packaged and deployed, Azure Container Apps will then automatically create a new revision based on the updated container image that you're pointing out as well. And then the new revision is deployed to your Container Apps environment. And Container Apps seamlessly handles the deployment and the transition without ensuring that your users are affected by any downtime during that during that deployment. But it depends on whether you're using revisions, how you've got your replicas set up, and whether you want your CI/CD deployment to instantly happen. In the real world, you'd be going through and doing testing from your test environment, so your Azure Container Apps registry, your Container Apps registry into your test Container Apps, doing some testing as part of the safe deployment practices. So you do testing in your test environment, make sure that it works, make sure that your features, make sure that things like your application can talk to other services. And then by the time you've deployed to production, you know that your services are going to work, and then you can either flick them over at 100% or look at revisions, which is what we're going to talk about shortly as well. So Azure Pipelines does require your source code to be in a version controlled system. Azure DevOps supports two forms of version control, so Git and Azure repos. Any changes that you push to your version control repository are automatically built and validated. They can be. So for example, if we go back to the Azure Pipelines here, we can see a trigger. So trigger main, what this means is that this pipeline will automatically run if it detects that an update has been, a new commit has been made in the main branch. So if we go into files, we can see we've got a couple of branches here, and one branch, and that's called main. So in proper, what you usually do in a production system is that if I was to make a change, I'd be selecting new branch. I'd be going feature/add, I don't know, new code. I would create a branch off main. I would make my changes into that branch. And then when I'm ready to push it to production, I would do a pull request to pull my changes from my branch into main, which is usually classed as your production repository. And then once that's done, the pipeline will automatically trigger based on new commits into main. So you can control this method to make sure to keep your pipeline running. So automatically trigger a deployment if new changes happen in main, go through approval steps. You can also change this trigger to none. So it means that if you make changes to the main branch, the pipeline doesn't automatically run as well. But that goes into the conversation around continuous integration and continuous deployment. So a trigger, like I talked about earlier with the main, tells the pipeline to run. The pipeline is made up of one or more stages. So a pipeline can deploy to one or more environments. So you could have one pipeline deploying to dev, one pipeline deploying to prod as an example, but it depends on how you want to structure those out. And each job runs on one agent. So a job can be agentless, but agentlet jobs are limited to few out-of-the-box tasks. So in our example, and for the purposes of the applied skills, we're just using a single self-hosted managed agent, but you can also have different jobs in different stages running on different agents. So you might have some using the Microsoft hosted agent. You might have some tasks that need it to be deployed into your own self-hosted agents as well. So you can control what stages and what jobs run on what agent if you want to, but my suggestion is keep it consistent, keep it the same. We're almost at the end. Yep, so I've already talked a bit about this. So agents can play a pivotal role in ensuring that your pipeline runs smoothly and effectively. Within the Azure pipelines, you have three types of agents to choose from. So the Microsoft hosted agent, the self-hosted agent, and Azure Virtual Machine scale set agent. So The Microsoft hosted agent. So if your pipelines are housed within Azure Pipelines by default out of the box, Microsoft hosted agents offers convenient and hassle-free approach. Because Microsoft takes care of the maintenance and upgrades for you, allowing you to focus on your core tasks. Each time you run a pipeline, you receive a fresh virtual machine for each job, ensuring a clean and isolated environment every time. That means you can run your jobs without worrying about the underlying infrastructure. There's a caveat there as well when you start to think about this in production, because if you finish one job and you want to carry over steps or data, so for example, if you're doing a Terraform deployment, usually what you would do is you would run a plan before you run an apply. So by default, with the Microsoft self-hosted agents, you would run a plan as one job, and then you do apply as another job, and you're switching over between two different agents. So when the apply happens, it's going to fail because it means that the plan was completed as a previous step hasn't carried across. So when you go and when you try and do a apply based on the plan that was previous run, it's going to fail because it can't find it. And that's when you start to look at things like artifacts and being able to export the plan into an artifact file and then make sure that that's brought in and imported into your step where before you go and do the apply as well. Not part of the applied skills, but just worth mentioning. So you've got your Microsoft hosted agents. Then on the other hand, we've got self-hosted agents. So like I've got set up here, where it's a Windows-based VM, or you can use Container Apps jobs environment as well to run your own agents, giving you the ability to control and manage your own setup. You can install dependent software needed for your builds and deployments. Unfortunately for me, I failed in this step because I didn't install some of the dependency tasks needed. So for example, the Azure CLI, and I would have needed to install Docker as well in order to do that. But you don't need to worry so much about that within the applied skills credential because that environment is already created for you, but you do need to know how the pipelines work and how to deploy from your container app registry to your container apps environment as well. One of the additional benefits of self-hosted agents is that you can control the cache and persist your data between runs as well. So like I was talking about earlier, with Microsoft hosted agents, if you were doing a plan and apply as separate steps, an example, you would be running on two separate virtual machines. But when you're running in a self-hosted agent, you can actually control the cache, and you can have the jobs running on the same VM, so you don't need to copy you don't need to worry about artifacts and copying from one step to the other. And lastly, you have Azure Virtual Machine scale set agents as well, which allows you to use the scale set's ability to auto scale to meet demands on what you need. Because like in this example, I'm just using a single virtual machine running Windows installed on my network. But if I've got multiple teams, multiple use cases, I want to be able to scale that capability out across the teams and know that there's always going to be an agent that can run when I need it to be, instead of waiting for it to complete another task that may be done by another person or another team or even my own pipelines running. I want it to be able to scale out depending on my demands. And so you can use virtual machine scale sets to do that as well. And yeah, I talked about this earlier, but this is essentially the step of setting up your self-hosted agent as you go in and create a personal access token. And then you go, which only just needs the agent pools, read and manage, and deployment group read and manage scopes. Then you copy the token, you deploy the agent software, and then you configure it. Yeah, and in my example here, I have put in my pipeline, my Azure Container Registry password, but what I should have done is made use of variables. So that allows me to go ACR password, put in the value in here, blah, 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 keep it a secret. And then that allows me to call the variable up without having the information as clear text within my pipeline as well. But for this demonstration, I wasn't really worried about. So you can have two different variable types. So user defined, system assigned, there's environment assigned, but secret variables are probably what you're going to be making use of the most. I've jumped ahead a bit, but that is essentially it. I did want to show you one more thing though. I will end on it because I did touch on it earlier. So if we go back to our container apps and then we go into revisions and replicas, I talked about single mode versus multi-mode. So at the moment, we saw it earlier where it automatically created a new revision after we added in the scale rule. But what if we want to control the information, like we want a new revision that uses a suffix of v2? We wanted to make sure that only 25% of our traffic is redirected to our new revision, for example. How would we go about doing that? So in order to do that, we're going to go to revisions and replicas, and then we're going to change the revision mode from single to multi-revision mode. So we're going to confirm to make that switch. We're going to wait for that to make that switch. I should have known I shouldn't have got this type of in an hour, because it's a lot of this full day workshops that people are training in order to help you to learn and complete the applied skills the applied skills session as well. And I was trying to do it all in an hour, but hopefully I'm running through the general basis of what you can do and how these work together for you anyway. So we've changed our revision to multiple revisions. So that allows us to, now we can specify a label, and we can also change the traffic criteria in here as well. So at the moment, we've got 100% traffic going to this revision. So what we can do is we want to now create a new revision with the v2 suffix. So in order to do that, we're going to go and click on create new revision. We're going to specify a name. So based on the revision that's running, we're going to enter in v2. We're going to make sure that our container image is selected. So we can also come in here and update based on the revision. This is where if you had multiple versions of your image and you wanted to run the latest version with a different version of your Docker image, this is where you'd come in and you change the image tag to meet what you wanted to do based on the revision. But we've only got the one version of it in our container registry, so we're just going to leave them as is. But we can allocate and change different things in here as well. So the health probes, any volume mounts, and the version of the image that we're running as a different revision. But we're just going to make sure that this is selected. We're going to click create. And we should see that. And we can see that it's now activating in the revision. So we can see that we've now got our V2 revision being created and our current revision still running with 100% of the traffic. And because we're now running in multiple revision mode, we can see that the single, in the previous example, within the single revision mode, it actually deallocated and deactivated the previous revision for us automatically. But because we're running it in multiple revision mode, we now have these running simultaneously, and it hasn't touched the other one. So we've got our V2 revision now, so that revision could be based on a new version of our container, based on different requirements, different variable types. It doesn't matter. But now we want to redirect traffic to it. We can come in here and we can change this from like 80% of traffic going here to 20% of the traffic going here. Fairly easy. But what if we wanted to do it based on the V2? So example, what's going to happen here is that we're going to hit the Container Apps endpoint, which is automatically going to redirect to the active revision. In this example, it's going to tell the load balancer that 20% of the traffic will be allocated to this one, and then 80% of the traffic will be allocated to the other one as well. So we can come in here and change that. But what we're going to do first is we're going to go, now that we've got our second revision created, we're going to go back to our container app. We're going to go to Ingress. We're going to make sure that traffic is enabled. We're going to specify traffic from anywhere. We're going to specify, make sure our ingress type is HTTP because we need that, because we need it to match our scale rule. We want to ignore client certificates. We want to ensure that transport mode all automatic. And secure connections, allow all traffic. Going to enter in, we can add additional TCP ports. For example, in here we could specify 5,000. And this is where we can enable different, we can really do sort of port translation from one port to another port and allow ingress within our container apps environment or out of our container apps environment from one container app being able to point and talk to another container app with using we're just going to just add in 5,000 in here. And we're going to save this. Invalid port mapping. Cannot specify additional when specifying ingress. Oh, I should have put it in here instead. Because I'm not doing any of the additional ports that I was telling about earlier. And this is the endpoint to connect to that revision, which is not running because my container app application doesn't have HTTP. Would have been better just having a single hello world web page up. So yep, we've got our container app, we've got our revisions, we've enabled ingress on port 1,000. We've got it running. What we can do in here, we can go and change the label for our V2 to be updated. Then we can do that to current. We can change the traffic. And this will allow us to specify, based on the ingress settings, that if we're running this as an example label URL, so instead of when you're looking at productionizing your environment in the real world, you may not want a lot of the information or automatically generated revision names, especially when you're doing testing, or you may want to redirect specific things to different endpoints, like especially if you've got Azure Front Load Balance, Azure Front Door in front of it, wanting to redirect from one area to another. You can use labels to make sure that you're redirecting to the right, like the updated or the previous version, or V2 versus V3. You can use labels to help give you a friendly name based on that, and then you can use this as well to redirect your traffic from 80% to 25%. I can't do maths. So labels, traffic, multi-revisions. Yeah. I'm almost out of breath, but thank you for sticking with me, guys. Hopefully it's been very helpful. I wish I actually had paid a lot more attention to the Azure DevOps agent deployment, and made sure that I had deployed the Docker dependency runtimes and the Azure CLI in order to actually get it to go and work. But I aimed to cover the basis of what you're going to need to learn about working with container apps and the applied skills credential. Any last questions before I finish? I'll stop recording anyway, but thank you all. If you have any questions, feel free to reach out through social media. The recording will be up later today, and I'll share the slides as well in the Learning Room community. So thank you and have a nice day.